G'day, I'm Evan, and I'm going to be talking about Introduction to Physics, and I have to talk quietly because my flatmate has just fallen asleep. Physics is an extremely easy subject, well, at least I find it, because I got it explained to me in a way that actually made sense. Many teachers out there basically make their students scared of it before they even begin, just by using convoluted language and formulas that people don't understand. So let's start from the basics. What is physics? And many different people will have different ways of explaining this question. What is physics? What the hell is physics? Really depends on your own interpretation of the subject, but the best way I think of explaining it is basically looking at what we call a system, which is just a fancy word for something. So let's say we define our system as a ball in a room with nothing else in it. Okay? Looking at a system and being able to, based on what we know about that system, predict what will happen in the future. So basically it's a way of predicting the future, which is kind of cool. So let's say we have a ball in the room by itself. We know everything about this room, let's assume. We know the ball's position, we know its speed, we know everything we can know about it. Therefore, we can know what's going to happen in the future because we know everything that's acting on the ball and everything that will ever happen to the ball, therefore, if it's in its room by itself. So, let's say it's in its room in a position X and there's nothing acting on it. At time whatever, that ball's going to be in the same position because nothing's acting on it. That is predicting the future, and we just get more complicated from there. So our systems become different, and our predicting the future becomes harder and sometimes impossible. So something very easy, say a car is driving down a road with a constant velocity of 40 meters per second, and I'll explain what that means soon. It may seem harder than the ball one, but it's actually quite simple if we think about it. It's moving at 40 meters per second. What's going to happen? What's its speed? Or what's its distance covered at t equals 5? That means 5 seconds after when it starts. Well, that's quite simple. If we're saying it's moving at 40 ms to the negative 1, how do we get distance? And I'll show you this in a second. 5 seconds equals 200 meters. So we've predicted the future. We've predicted that it will travel 200 meters. How do we do this? This is an important thing to look at in physics, and it's the crux of physics, really. If you see these little letters and stuff up here, these are called base units. Okay, and this is quite a fundamental concept in physics. We measure everything. To predict the future, we have to measure stuff. Okay, we can't just say that ball is there and nothing's acting on it, or something's acting on it, but we can't say how much, else we wouldn't be able to define anything. If I didn't know what this value 40 was, if I just said it was going at a speed that was quick, I couldn't determine how far it had gone. And if I didn't know the time, 5 seconds, I don't know, after a bit of time, I would never be able to determine how far it had gone. So we need to measure these, and we define our own measurements, okay? And I'll explain what this means right now. We took an arbitrary length, x, and basically said this is 1 meter. If you don't know what arbitrary means, we're basically saying we took a random length and said this is going to be 1 meter. Therefore, someone over the other side of the world can measure something and say this is 40 meters, and then you could replicate it here and measure out something 40 meters. That's the use of it. If we didn't have meters, we can have 40 meters, and we could say that we made up this thing called a cling that was 2 meters long for one cling, and you could just basically say, okay, well, it was 20 clings long. It doesn't matter what the measurement system is, as long as it works, and in this case it does. And then we made a massive rule that currently resides in France, I think, that said, okay, this will always be 1 meter. And in fact, they have derived better ways of, because that rule will always change with length, in the heat and things like that. We defined something that will never change to be 1 meter. So forever, 1 meter will always be this certain length. We did it with things like time as well. In fact, the way they did time is they had this atom that would flick between states, and they said, okay, well, 1 second is a certain number of flicks for that atom, and that's actually how, if you've ever heard of atomic clock, how it works, because its second that's what the second's defined on. It's defined on that clicking, and it basically measures that clicking and tells you a perfect time. It can never be wrong because that's what seconds defined as by that clock. So that's how it works. So let's delve into the units in physics. I've told you that physics is used to predict the future, and we use these units and stuff. So what does all that really mean? Okay, well, the easiest example I can think of, the first thing you'd ever learn when you went into a physics room, is basically this, and I should probably clarify this first. As you can see here, there are a bunch of things we can measure as the fundamental things. So what I mean by fundamental is just the really important little things, and you'll see what I mean when I tell you which ones. So we've got length, which is in meters, mass in kgs, time in seconds, electrical current in amps, and Kelvin, which is just another way of measuring temperature, like Fahrenheit or Celsius. So those are all really important, and we don't have to worry so much about mole and luminosity, but those 5 there are the fundamental ones, and everything complicated can be made from them. For example, energy, which is work, which is force times distance, which is MAD, well, because force is mass times acceleration, which is mass, and acceleration is meters per second, and I'll explain that in a second. So mass squared s -2 kg, and that's what energy is. It's kg m squared s -2, and this may seem odd. Like, what does seconds have to do with it? But when you look at units and we go further in, you'll understand why this is. It's just something we have to do, and it will all be explained in due time. It may seem very odd, but it makes sense. Okay, so if we take the simplest thing, which is this equation, which they'll give to you quite often in level 1 physics, velocity equals distance over time. What does this mean on a fundamental level? What the hell does this equation mean? It's just a complicated thing. No, it's not complicated at all. Really, all it is taking the units that we've talked about and applying them to exactly what we wanted them for, which is to be able to measure things. Instead of just saying, oh, that car's going quickly, be able to say, oh, that car is going at 40 meters per second, and someone else can go, oh, I can drive my car at that speed as well. I don't have to drive along next to that car. We can do things in the future without having to watch them while they're happening. So here we basically all we're saying, and the word velocity is quite confusing, so for now, until we get further, I'm just going to call it speed, because that makes it much easier for people to understand. But just note that velocity is the correct term in physics, and if you want to know right now, basically velocity is not something that is constant or average. It is something that happens in the moment, and it's in a straight line, but that's really it has direction. That's basically what it means, but we'll talk about that later. So how do we calculate speed? Well, it's distance over time. What does that mean? Basically it's saying, okay, well, the speed is how much distance you cover over the amount of time it took you. So if you were traveling down a 100-meter road and it took you 5 seconds, your speed would be 100 meters divided by 5 seconds. That's just how we define speed. This is nothing that is inherent in the universe, or God told us to use this. We have made it up. So don't try and prove this into your head or try and work out why we chose this. It's just what we chose. Okay? So we needed to measure the distance. We needed to know how long it took us to do it. And this is the way we chose to express it. Okay, so what does that equal? Well, that's 20 meters per second. Okay, which, if you know your math, m over s can be represented, or is equal to, ms to the negative 1. They are exactly the same. Okay, if you don't know this, then I suggest you go away and do some math and learn. I'll do a little bit for you now, just to to clarify. So, for example, if I had 1 over s squared, this is equal to s to the negative 2. Okay, same thing. 1 over s power 3 equals s to the negative 3. Basically, we've just taken it up to the top and we have to put a negative before the power. Okay, that's it. So this is really fundamental of physics, is these units, and we can build upon these, and we'll talk about it in future lectures, hopefully, if I do more, which I'm hoping to. If you have any questions or anything, please feel free to post. I will probably comment back. I'm doing a second year at uni at the moment in physics, so I know most of this pretty well. It's just a really abstract thing to try and explain, and I suggest you look around and don't settle until you understand it, because if you do, you will just put yourself completely in the deep end using equations like F equals ma, and then building upon that by, you know, using a to be delta v over delta t, and then making that m delta v equal to delta p, which is momentum, and you get all these equations going which you won't understand why they work and how they work, and it's just not going to be pretty. So go away and learn how all this works and stuff. I'm going to do a couple more things here to show you what I mean, okay, by base units. For example, energy, okay, if we take this equation, work equals force times distance, as I did above, equals MAD equals the units for that. Okay, basically MAD could be equal to 20. Okay, it's scalar value, which means its magnitude. Say m was 1, a was 1, and the distance was 20. It would have 20, and then the units, because we have to put units, we can't just say it would have a value of 20. We have to say it would have a value in the units for joule. Energy is joules, so it would be 20 joules. Okay, but joules is just a simplified thing for what's above, which is kg m to the power 2 s to the negative 2. Okay. Now look at this. This is quite cool. Have you ever seen this equation, m equals mc squared? Well, E is just a measure of energy, and work is a measure of energy. So if they're the same thing, the units should be equal, right? Surely. Okay, well, let's have a look. Kg is masses in kgs. Speed is in ms to the negative 1, right? If we square that, what do we get? Okay, well, kg is still the same. M to the power of 2. Okay, well, that's m squared. S to the negative 1 to the power of 2. Okay, what happens when powers are in brackets? They just multiply, okay? That's negative 2. Oh, look, they're the same. Isn't that amazing? That happens throughout physics. Okay, and we'll understand that basically all that the units are for is they don't provide value or anything like that. They're basically just saying what we used to make up what we've calculated. Okay, so meters per second, or velocity, has a value, and then we basically say, okay, well, what that value is the number of meters divided by time. And this is exactly the same with energy, and they always have to equal. You can't have one energy thing, one measurement of energy being in kg m to the power of 40 is to the negative 2, and another one being kg m to the 2 is to the negative 2, which is correct. One is correct, always. Power has certain units that it's always used. Force has certain units that are always used. Everything in physics has certain units that are always used. And we'll work on this and build upon it in the next lecture. Cheers.